Section 10-2, Part 3. Determining if figures are similar. Is triangle MNO similar to triangle PQO? Explain. Now let's look. In order for us to prove that these two triangles are similar, we must find a mapping and end up being able to show that they have the same scale factor. If they are similar, then angle M is congruent to angle P, angle N is congruent to angle Q, and angle O is congruent to angle O. Okay? So O and O would be congruent. M would be congruent to P, and N would be congruent to Q. Okay? So, we must first of all determine a mapping, and then I see that this triangle is larger than this one, so we need to find the dilation and then see if all of the scale factors are the same. So the first thing that I'm going to do is I'm going to place my little triangle here. Okay, I have MNO. Now what I'm going to do is I'm going to perform a 180-degree rotation. I'm going to take this triangle, I'm going to rotate it 180 degrees. I'm going to bring it around and rotate it 180 degrees, and it's going to end up right here, okay? Right here. So there is the triangle rotated 180 degrees. So now let's use this next picture here. You see where the triangle was taken. It was rotated around and ends up right here, okay? So I have, this is N prime, M prime, and O prime, okay? Notice the center of rotation, O and O prime would be the same, okay? So the question is, now we have a dilation. We see that triangle PQO is the dilation of triangle M prime, N prime, O prime, all right? So we've got to determine, are all of the scale factors reducing to the same fraction, okay? So let's find the scale factor of each side. We can easily find the vertical scale factors because we know that ON and OQ correspond. ON and OQ. So ON is the original, it's going to go in the denominator, and OQ is the dilated side. We also know from our similarity statement back up here, O goes with O, Q goes with N. So looking at sides, we know that OQ corresponds to ON. All right? We know that NM corresponds to QP, okay? And then we also know that the last one, we know that MO corresponds to PO. Okay, we know that those correspond, MO and PO. So that's what I'm going to be using and trying to determine if they all have the same scale factor. So looking at the OQ and ON, on a vertical axis, you can count the squares. So let's count them. 1, 2, 3, 4 is ON, O to N or O to N prime. And from O to Q, it's 1, 2, 3, 4, 5, 6. So I have a 6/4 scale factor. Dividing both of those by 2, since they're both even, I end up having a scale factor of 3/2. Now let's determine my scale factor between N prime and M prime and Q and P. All right? So N prime and M prime go in the denominator and QP goes in the numerator. All right, the original always goes in the denominator. So from N prime to M prime, that gives me 2. And then from Q to P, I've got 1, 2, 3. So 3 over 2. So both the vertical line and the horizontal sides of the triangles do have the same scale factor. So the question is the slanted side of the triangle, O to M prime, O to M prime, and O to P, O to P. The question is, do they have a scale factor of 3 over 2? So what we're going to do, first of all, is we're going to take the ordered pair that represents M prime. M prime has an ordered pair of, to the right, 1, 2, and down 1, 2, 3, 4. So 2, negative 4. All right, so to determine if OM prime and OP have the same scale factor, we will multiply each one of these numbers times the scale factor of these two sides. So I'm going to multiply 2 times 3 over 2, and I'm going to multiply negative 4 times 3 over 2. And this will give us the ordered pair that should be for P in order for us to have a scale factor of 3/2. So looking at this, 2 times 3 is 6, 1 times 2 is 2, 6 divided by 2 gives you 3. So I'm going to place that 3 right here. P should have an X value of 3 if it has a scale factor of 3/2, if this side does. Now next, negative 4 times 3 is negative 12, 1 times 2 is 2, and 12 divided by 2, negative 12 divided by 2 would be negative 6. Negative 6. Now the question is, does P have an ordered pair of 3, negative 6? If it does, then yes, we have the same scale factor of 3/2 as the other sides. So let's look at the ordered pair for P. All right, the ordered pair for P would be to the right, 1, 2, 3, and down 1, 2, 3, 4, 5, 6. So yes, it does. Therefore, we have confirmed that all three sides have a scale factor of 3/2. So now I can say, yes, these triangles are similar after a rotation of 180 degrees, and a scale factor of 3/2 maps the two triangles together. Therefore, yes, these two triangles are similar. So my answer would be yes, and I have explained why. We did the 180-degree rotation, and then we proved that all three of the sides had the same scale factor of 3 over 2.